Okay, in this video we'll look at multiclass classification. And we'll see how this builds on our previous discussion of multiclass classification with logistic regression. It's very nice how the structure of logistic regression builds up to give structures within neural networks. It's a good way of thinking about neural networks. Right, now remember, one of the strategies for multiclass classification with logistic regression was to do one versus rest. And we could do this with any binary classifier. Suppose we have k classes, and for each class you get a threshold. You get a h function that is used to classify. So what happened when we did one versus rest was you get a number for each of the k classes, and the number that was biggest was the one that you chose. So that's illustrated here below. So if I'm going to test this class, I call all of these ones and all these zeros, and I would use my logistic regression to get an output. The score, whether the instance was in this class 1 or the in class 0, would depend on my score with my h function. Right. So I have a function here, h1 of theta. Right. Similarly, if I want to test this class, I create another classifying function that would create another threshold, and the other threshold will give me a function, like a logistic function, h2. Similarly for the third class. Right? So 3 classes, 3 numbers. The class that we chose is the one that gives me the largest value of h. Right? Now, what's key here is that all classifiers use the same features, so they're using the same inputs. So why not use the same inputs in a neural network structure and do all 3 in a single neural network structure? And we'll see how that works in just a moment. Now we could use a separate network for each of the 3 classifyings, right? I could use one network for this, one network for this, and one network for this. But why not, instead of having 3 networks, just have one network with 3 outputs, right? So here you have 3 networks. We're going to share some weights, right? So this would give me h1, this gives me h2, this gives me h3, and we put them all together. Now notice these weights are being reused. These are the same weights for all 3, but then the weights are different here. You're combining them differently. Right? So there is a question whether there's too much reuse or not, but we can try. Right? So we can get the 3 functions this way. Now I mentioned that if you have multiple layers, you can get any output function. So that's the case here, that we can get any triple of different output functions if we put enough layers. So my output is 3 values, not just 1. And I can think of this output as a 3-component vector. And I would assign vectors to different outcomes. For instance, if I have neutral, happy, sad are the 3 categories of faces, I can assign the vector 1, 0, 0 to one type, vector 0, 1, 0 to another type, and a vector 0, 0, 1 to another type. This is called one-hot encoding. So we can see specifically how this works on the next slide. Each one of these rows represents one instance, one data instance. In this picture we only show 2 inputs. Now you could have n inputs. And we're classifying between 3 classes of faces, neutral, happy, sad. So suppose the first instance was a neutral, second instance was happy, third instance was neutral, etc. So we can call those classes 0, 1, and 2. However, we can't have outputs of 0, 1, and 2. We can only have outputs like this. So I'm going to assign 0 to the first, I'm going to assign 1 to the second, and I'll assign 2 to the third. And these y-hats will be my targets when I train my neural network. Not the 0, 1, and 2, but the vectors. Right, so I have one of 3 targets. And as I said here, my output is a vector of output. So the vector of outputs is compared to the vector of targets. So in general, if I have a K-class problem, you may have L layers in your network, and then we have the usual structure, right? You go to Z2 and A2 comes from Z2 and so on. So this is the structure we've seen before. Okay. Get our final ALs, and we want K classes at the end. And we'll interpret those K classes at the end as our final criterion. So this NL should be equal to K. So what I would have to do simply is set up my network in such a way that the last layer has K nodes. Then my training set would have instances, and the labels would be these one-hot vectors that has a 1 in one component and 0 in the other components. And then I just do training the usual way with neural networks. Now I'll get more specifically into how training works, how the weights are varied during training in subsequent slides. Right, the number of output nodes is K, the final output is a K-dimensional vector. And that's it for multi-class classification. A simple extension of what you saw in logistic regression.